Hello everyone and welcome. In this lesson, you are going to learn about Solidity basics and the Remix IDE. So Remix IDE is a tool where you can experiment with Solidity smart contract. You can even deploy them and maybe you can even create full-fledged applications or decentralized applications. In our case, we are going to do a little experiment. We are going to learn about Solidity, and I encourage you to do the same thing. While you are going through the tutorial, try it on the Remix IDE. As you will see, it's a very convenient tool and many developers like it, and we will see why. This is the Remix IDE website. If you just type Remix IDE on your browser, then you are going to see the website. For this website, you don't need to log in or anything, it's just going to work. Now, that's the scene that you are going to see once you are in the website. And as you can see, we have a panel on the left side. Here we got contracts. And we have a couple of contracts that's already been defined for us. So we got the storage.sol, owner.sol, and ballot.sol. As you can see, this .sol is the Solidity extension. We call Solidity files with .sol. We have more tools here. So this is to search something on file. And this is to compile our contract. We can have this deploy here so that we can deploy and test our contracts. And we have a debugger. So let's start with creating a contract. I'm going to create a new contract. Let's say new file, and we are going to have counter.sol. Very simple example, but it's used heavily in the beginning, and we are going to see some important concepts. You don't have to understand what we are doing here. It's just that I want to give you an idea about what's ahead of you. And don't worry, Solidity is not that complex. Since Solidity is developed for smart contract development, it's more of a restricted language and it's easier to get used to writing Solidity contracts. That being said, let's start with our first contract. Here I'm going to paste something. Let me explain quickly. So this is a license identifier. This defines the license of your smart contract, which you should put. And then we have this Pragma Solidity and the version. Solidity works on Ethereum virtual machine. This means that anything that's compatible with EVM, you can write Solidity contracts on it. And Scroll is one other example. So with the Pragma Solidity, we are saying, okay, I'm using this version because maybe the next versions can break the current version and we cannot update the contracts once they are on the blockchain. Hence, we want to give the exact version number so that the Ethereum virtual machine know that, okay, this contract is going to work on this version. So I'm going to put this contract on this version of the Ethereum virtual machine and it's going to work. That's why we have this Pragma Solidity. And as you can see, it says 0.8.25 and I have this little symbol on the left, and this means that above. So anything at this stage or above is going to work with any version this or above, but this will not include 0.9. Here we have 25 minor updates and 8 major updates. So this is going to include all the later minor updates, but once it's 0.9, then it means that our contract will not work on it. At least we are not saying, okay, put this contract in this version. So now let's start defining our contract. The first thing we are going to do is we are going to say contract, and we are going to put the name of the contract. In our case, it will be counter. Again, it's just simple. The contract keyword and the contract name, which is the counter. Now, let's create a variable first. So you can actually think these smart contracts, if you are coming from an object-oriented programming language, you can think these contracts as classes. So what we are going to have is we are going to have data on these contracts, and we are also going to have functions. So we are going to manipulate the data or read the data with the functions we define, and that's what we call a contract. So the first data that we are going to create is obviously the count. So I will say uint 256 count. So let me explain. Uint means unsigned integer. So it's integers 0 or above. So only the positive integers or the 0, but not the negatives. In many cases, we want to work with 0 or positive numbers in Solidity and not the negative numbers. For that reason, we have this unsigned integer. Again, it's going to be 256, and this means that it's 256 bits. So we can have 2 to the power of 256 different type of numbers, which is a very, very high number. In many cases, you don't need that much. For that, we have different versions, like you can say 128. So you would have 2 to the power of 128 different values, or you can say 64 and 32, and we can also have 16 and 8. In our case, we are going to say 256. If you don't put anything after the uint, going to convert it to 256. Now that we have our counter, and we also want to say this is public, so it can be accessed publicly. Now, before moving forward, now it's correct. Now it's contract. Now let's create our constructor. We are going to say constructor, and this is a special type of function because it's going to run once we deploy our smart contract. So after we deploy, this function is going to run, and it's going to run just one time, and that's going to define our contract. So whatever we want to initialize in the contract, we can do it in here. In our example, I'm going to say count equals 0. As you can see, we created the count here, but here I'm initializing it with 0, or I can change it. Maybe I want to initialize it with 1. After the constructor, let's create another function. Now, the first type of function that we are going to create is the query functions. Query functions mean that I am just reading data from the blockchain, and I'm not changing, modifying, altering any data. It's free. We don't have to pay gas fees for query functions because blockchain is publicly available. Reading data from the blockchain, especially from EVM-based blockchains like Scroll, is free. But with the execute functions, we actually alter or change some data. So if I want to learn what the count is, I can call getCount, let's say, function. But if I want to change the count, then I will need a setCount function, which is going to be an execute function. And since we are going to change some data, we are going to pay gas fee for it. Now let's say function, and that's how we are going to define our functions. getCount, and this will be our query function. We are going to say view returns 256. So let me quickly explain what's happening here because there are many things happening here. First, we define our functions with the function keyword followed by the function name. Here we have parentheses, and if we have any parameters, we are going to put it in here, but in this case, we do not have any parameters. This view keywords means that I'm going to read some data from the contract, but I'm not going to change any data. If we just read the data and do not change the data, we are going to say view. And then we say, okay, this function returns this type. And we directly type the word returns, and inside the parentheses, we put the type that we want to return. And here, what we are going to do is we are going to say return count. And we missed just one thing. We need to identify how to access this function. We are going to call these function identifiers. As you can see, this is a public variable, but we don't know if this function is public, private, internal, or external. And don't worry, you are going to learn what does each type do in the tutorial. So here we are going to say public. So it's going to be a public function. It means that it can be accessible from inside of the contract and also from the outside of the contract. Next, let's create another function, and we are going to call this increment. We are going to say this will be a public function. I'm not showing everything here so that it wouldn't be too crowded, too many new terms. That's why we are using the same identifiers again, but there are many ways to define these, and this is not the best way. For example, it doesn't have to be public because we are not accessing this from the inside of the contract, so it doesn't have to be public. It can be external, but since I don't want to make this too complicated, just stick with me and try to understand what's happening and try to grasp in general how the Solidity as a programming language feels and what will be its look and syntax. So it's just an overall video, it's just an overall, let's say, explanation. You don't have to understand every bit here. What we are going to do here is we are going to say count plus plus, and that's it. We are just going to increase the count here. And finally, we will create another function. We are going to call it Decrement. Let's say this is also public. And we are going to do something very similar, but we are just going to decrement it. And let's say this is our data section. This is our constructor. This will be our query functions. We just have one function, but we could have more. Let's say these are the execute functions. Now we created our first contract. Let's see if it's going to work. Here I'm going to go to Solidity compiler and compile this counter.sol. With this compilation, I'm going to learn if I have any problem in the code. If I have any problem, I can see here, but as expected, it looks fine. And we can also see this from the green tick. And then I'm going to go to this deploy and run transactions. Here I have the latest version of the Remix virtual machine. So this Remix virtual machine creates a mock blockchain environment inside your Remix IDE so that you can actually test your contract as if like it's on the blockchain. And here, as you can see, we have a couple of different addresses. The first one I just used a bit. It doesn't have 100 Ether, but as you can see, we have different type of addresses we can use. I'm going to use this address ending with EDDC4 to deploy the contract. We have our gas limit, and if we are going to pass any value, any tokens with the function call, we can put it in here. And what we are going to do is we are just going to go to here, the contract part, and this is the contract that we want to deploy. We only have one contract because we just compiled one contract. We have to compile before we deploy. Now I'm going to say deploy. It looks fine. And here, as you can see, I have my example contract. As you can see, we have the contract name. And if I expand this, as you can see, we have different options here. First of all, just notice that our variable is public. And since it's public, I have this function automatically. So for the public variables, I don't have to create a function like this getCount, which returns the count. But since it's created for me, I didn't have to type this, but I just want to show you. So if I click on the count, as you can see, my count is 1 because with the constructor, we initialized it with 1. But if I click the get count, again, it's 1 because they are doing the exactly same thing. If we have a public variable, then we don't have to create a public function to just retrieve that variable unless you don't want it, because since many are coming from other programming languages, this is not very common and many people choose to include anyways. But it's not necessary. Let's click on the increment and then we are going to check if it's work. I'm going to click on the count and as you can see, it's 2. And again, here it's 2 because they are doing the exactly same thing. Then I'm going to click increment again and the count will be 3. Increment again, the count will be 4. And this also changes. I just didn't check it. And let's say decrement and it's 3. Decrement 2 and decrement 1. As you can see, our execute functions are this yellowish or orangish, let's say, color, and our query ones is more like this blue kind of color. So you can differentiate them and you can try writing your contract here. Then you compile on the left-hand side, you deploy and you test your contract. And this will be your workspace during this tutorial. And again, Remix is very beneficial, not just to learn, but also even create, test, and deploy contracts and real contracts. It's actually a full-fledged IDE. So I encourage you to use Remix IDE during this tutorial. And after each part, after each section, you learn something, you can come here and test the contract if it's going to work, and you can make a little twist. Only after that, we actually learn something. If we read it, we can understand it. If we hear it, we can understand it. But to learn it, we have to try it. So Remix IDE is a perfect place for it. Now, again, this was a quick interview about the Solidity and the Remix IDE. Do not worry. You are going to learn Solidity much more in depth during the tutorial. And at the end, we are going to look at an example. Thank you very much for listening on this video. And I will see you after you finish the tutorial.